tell you how the thing goes. First of all, what we're going to do is we're going to write down combinations in what is called Yates standard order. And if you can remember to begin with combination 1 and then combination A, you can always remember how to finish this, because I then take the 1 and the A and formally multiply by B. So 1 times B is B, A times B is AB. And then I take those 4 and multiply by C. So 1 times C is C, A times C is AC, B times C is BC, and AB times C is ABC. That's the way I'd write the combinations down if there are factors A through C. If there were factors A through D, then I would add 8 more rows to this table. That is, I list here 2 to the P rows. In our particular example, we're going to be using P equal to 3, so I'm going to show you the Yates computations for the pilot plant example. And then I list the corresponding Y bars. So this Y bar was 60, 72, 54, 68, 52, 83, 45, and 80. The Yates algorithm proceeds by making several cycles of additions and subtractions of values in columns in pairs. So I'll bust these guys up into pairs, and for cycle number 1, I will add in pairs first. So I'll have 60 and 72 add to 132, 54 and 68 add to 122, 52 and 83 add to 135, and 45 and 80 add to 125. Those are additions of these pairs, defined or broken up by these lines here. And next thing I do is make subtractions in pairs, and the only thing that's at all difficult about this is to remember to subtract the top one from the bottom one. So 60, take 60 away from 72 and you get 12. That is, take 72 minus 12. 68 minus 54 is 14. 83 minus 52 is 31. And 80 minus 45 is 35. And that finishes the first cycle of the Yates algorithm. I'm going to do one cycle per factor. I'm going to make P cycles here of this addition and subtraction business. So I've done the first one. I need to do 2 more because this is the pilot plant example. So this is the BH squared example. Cycle number 2. The 132 and the 122 add to 254. The 125 and the 135 add to 260. The 12 and the 14 add to 26. The 31 and the 35 add to 36. Then doing subtractions in pairs, I take 132 from 122 and I get a minus 10. It's very important that I carry the minus signs. The 125 minus 135 is also a minus 10. the 14 minus 12 is 2, and the 35 minus 31 is 4. And that's the second cycle of the Yates algorithm. I have 3 factors in this example, so I'm going to do a third cycle. So there's cycle number 3. 254 and 260 add to 514. 26 and 36 add to, 26 and, what have I done here? This guy should be 66. 26 and 66 add to 92. Minus 10 and minus 10 add to minus 20. 2 and this should be 4. Boy, I'm not doing much of a job here. 2 and 4 add to 6. 260 minus 254 is 6. 66 minus 26 is 40. Minus 10 minus a minus 10 is 0, and 4 minus 2 is 2. There's the third cycle of the Yates algorithm, and I finish this thing off by taking the last cycle. So I take cycle number 3 and I divide by 2 cubed. So if I was doing the 4-factor Yates algorithm, I would be doing division by 16. Here I'm doing division by 8. If I take 514 and I divide by 8, I get 64.25. As a matter of fact, that turns out to be the grand average. 92 divided by 8 turns out to be 11.5. That is the main effect of factor A at its second level. That is, I can look over here and see an A on that second row and tell myself, oh, 11.5, that's the main effect of factor A at its second level. If I take minus 20 and divide by 8, I get minus 2.5, and that's B number 2. If I take 6 and divide by 8, I get 0.75, and that's AB22. If I take 6 and divide by 8, I get 0.75. That corresponds to the main effect of factor C at its second level. If I take 40 divide by 8, I get 5.0. That is AC22. 0 over 8 is 0. That is BC22. And finally, 2 divided by 8 is a quarter. And that is ABC222. That's a very slick little trick. It's a very methodical way to get one effect of each type, the effect corresponding to the high levels of whatever factors are involved, and I can get from that all others by simple sign changes. In addition to that, this is a very compact, efficient way to write things down and sort of stare at it and see what's big.